Mic check. Everyone hears me? Good morning, everyone. Welcome to the talk, the digitalization of the sustainable blue economy here. My name is Siggi. I come from Iceland. We are a very peaceful nation in Iceland. We are one of the two only countries in the world with no mosquitoes. I don't remember what the other one was. We have a very minimal number of volcanoes in Iceland, although we have some. We have had constant eruptions now for the last 4 years, but we still encourage people to come visit us. I mean, the airport isn't anywhere close to the eruption. It's some, 3 to 4 kilometers away. But the current eruption in Iceland is nothing compared to the one in 2010, where we really screwed you guys in Europe over. But what people rarely mention about the eruption in 2010 is that it stopped flights in Europe for over a week, and that essentially is a green project. We stopped carbon emissions for a week. That's what nobody mentions. It was the largest air traffic shutdown since World War II, which sounds like an achievement, but I'm not sure it is. My background is in physics and engineering, and space engineering to be exact. But I've set my sights on fish, hence I'm here at the Blue Economy. The problem we're tackling at my company called Greenfish, and we chose the name because it's very hard to misspell, is that we're tackling a problem in the North Atlantic, which is that sometimes when ships go out to sea in the North Atlantic, they just don't find the fish. And don't look away, Norway. I can see you're looking away. I know you have the same problem as us. The thing is, we have a quota system in Iceland and Norway, which means that if we don't find the fish, we sometimes lose the time window of actually fishing the fish. So we lose a lot. That means the fishermen lose their money, the part of the quota money. The fisheries, they lose their money. And we spend a lot of time on the sea, and the ships, they spend a lot of fuel searching for these fish, and if they don't find it, it's a huge loss. In the end, it means more CO2, less money for the fisheries, less money for the fishermen, and a lot less fish and chips for the rest of us. Which is what made us start Greenfish. What we've done essentially is we've taken a hell of a lot of data, former catch data, and historical weather, satellite, in situ data, and we've created this huge AI model that can just squeeze everything in, and for a given day and given species and given area, it can tell you, go fish there. It's going to be there, probably. But that's not what we're here to talk about. What we have today on the agenda is 4 talks. It starts with Andre Kovatariu from 10:15 to 10:30. He is the co-chair of the Digitalisation and Energy Task Force at UNEC, and he's based in Bucharest at the UN Economics Commission for Europe. After that, we have Mr. Pavel Dvořák, development manager at Bamita in Slovakia. Then we have Bartosz Lankowski from 10:55 to 11:10. He's the Safety and Drone Services Project Manager at the Port of Gdynia in Poland. After that, we'll have a short half-an-hour break from 11:10 to 11:40. And then we'll finish it off with Carlos Pino, who is the manager at the Portugal Blue Digital Innovation Hub project at Forum Oceano in Portugal. After which we'll do a panel discussion for 40 minutes from 12 to 12:40, and then 20 minutes circa about for questions from the audience. So be ready with some very exciting questions. So I agree with my Norwegian friends who said yesterday to keep it short and simple. I know you didn't come here to listen to me, so I'll give the word to the first speaker, Mr. Andrei Kovatariou.
Good morning. Thank you very much for the introduction and thank you for the invitation. I'm very happy to be here. My name is Andrei Kovatariou. I am the co-chair of Digitalisation and Energy Task Force, the United Nations Economic Commission for Europe. I'm actually based in Brussels, but I am Romanian, which brings me to your point. Actually, we do have mosquitoes quite a lot, so you know. But this year it's an election year, so we don't have mosquitoes this year. The politicians have decided to actually invest into that, so maybe next year we'll have a bit more. But do join us, do visit us. So I was asked to talk about the intersection of digital energy and the blue economy, which I must confess is quite a challenging topic to, or subtopic to address, because at the task force that I'm co-chairing, we are looking into, and we have looked into this intersection of digital and energy for some years, but the blue economy is quite a specific, it's quite a particular, let's say, subtopic of this spectrum, and it's quite difficult and it's quite interesting to look at. So it was a bit challenging for me and my colleagues that helped me to look into that, but I think it's a timely conversation to have, and it's a good environment to discuss about this. So first of all, what is digitalization? So like any other trendy buzzwords, each of us have their own definition of digitalization, and that doesn't mean that they are wrong. Maybe they are not comprehensive, but there are different definitions out there. The one that I actually like the most, and I think it embeds the most topics into it, is the one that Bloomberg New Energy Finance defined in 2017, which is basically the process of connecting various pieces, so different technologies throughout digital communication, so that we collect, share, and analyze data to improve processes and operation, including public policy. So the way digitalization has shaped and has influenced so many other sectors, economic sectors in the past decades, like telecommunication, transportation, logistics, it is also shaping, and it's continuously shaping and influencing the energy sector as well. Why is that? Is because it's basically creating new ecosystems. It's unlocking at production level, the transmission and distribution level, as well as at the consumption point. It's unlocking new ecosystems, and I'll come back to that a bit to talk about what are these new ecosystems. But why is it important for the power sector, for the energy sector, and what is the thing about this twin transition? What does that mean? So, as you know, over the past few years, we have faced quite some interesting challenges in the energy sector, triggered by the energy crisis, started in Europe, that had influenced or had generated a lot of other issues globally in the energy sector. But basically, this is a very old, some called it rusty concept, but I think it's more actual than ever, is the idea of the energy trilemma. So basically the balance that public authorities, businesses, consumers, at the end of the day, need to keep between security of supply, so having electricity or energy whenever it's needed for the demand, energy equity, keeping bills as low as possible, and environmental sustainability, so doing as much, or doing as much as we can for the environment, so having less harm on that. As you can imagine, that is pretty difficult to balance at the public policy level. Once you try, the practice shows that once you try to maximize one of these dimensions, it comes at the cost of at least one of the other two, if not the other two combined. So that's quite challenging. But the thing about digital and digitalization in the energy sector is that it improves decision maker and it informs decision making process to balance a bit more these components, because it is a matter of managing resources, managing intermittent generation of renewables, managing demand in a different way, and unlocking those ecosystems that I told you about. But what ecosystems are we actually talking? So the twin transition is basically this transition that is both on the energy side, so transitioning from fossil fuel utilization to cleaner renewable generation, but also adopting at the same time digital tools, so assets, hardware, at the same time with software, so platforms and options for services. So basically, this is the conventional energy system that has been used for decades. So as you can see, it goes from the generation to transmission and distribution and all the way to end users. So it's basically a one-way energy flow from generation to consumption. What is digitalization do is unlocking a new ecosystem that is not only a one-way, it's a two-way, and not only an energy flow, but energy and data flow. So transitioning from a one-way energy flow to a two-way energy and data flow. And in that sense, end users are basically an active component of the new energy systems, of these new ecosystems. The data that consumers, transmission system operators, distribution system operators, and generators are generating is creating this ecosystem that is basically balancing, analyzing, assessing, and taking decisions in real time in order to improve resource management, to improve demand and supply, and markets overall. And obviously, it's creating new services and new business cases and new ways of doing business in the energy sector. And there are many options, especially on the software part, but not only. The software part is unlocked by hardware, right? But there are many options, and some of them are listed over here at various levels of the power sector. So from generation to transmission to distribution to operations, market operations to retail, we are seeing more and more utilization of big data, of AI, of IoT, of digital twin, robotics, virtual and augmented realities, cloud computing, and so on and so forth. This table is actually, has been done a couple of years ago. If we were to look at it now, we will see more blue dots because it's becoming even more mainstream to use these technologies all across the spectrum from generation to consumption. What's the public perception about this? Well, at the task force, we have run a couple of surveys a couple of years ago to ask people what they think about that. People, meaning stakeholders involved in this process, so informed decision and informed answers. And the answers are quite interesting. So when we ask them what are the key barriers that are holding countries back from implementing digital technologies in the energy systems, the number one answer, or the highest answer, was the lack of awareness of the potential benefits of digitalization, which is interesting. It means that we are not doing our job explaining what are the benefits. Then there was the lack of funding for digitalization, which we actually agree with. We don't think that dedicated funds are available for that. And then lack of digital skills, which I would say it's a cross-cutting or a general issue, not necessarily in the energy system. Risk related to data protection and the cybersecurity, social concerns, and so on and so forth. So this is the spectrum of barriers that are impeding governments and businesses to actually adopt digital solutions at a faster pace. Now going a bit more specific, this twin transition and the blue economy. So there are various ways to look into that and to more granular ways to actually look into what that means, the digital transition, the twin transition in the blue economy. But just to simplify it, and I know it's the first presentation we will discuss about that, I just decided to put things into just two perspectives. But I'll come to that after this slide. So what does it mean, the blue economy, in a nutshell? It's about renewable energy that we can capitalize on in offshore environments. It is about the consumption at port level, at coastal level. And it's also about the ecosystems around islands that is also part of this blue economy. How can we integrate all these resources and demand and consumption is through digital platforms and through digital technologies, tools, and software. So again, for simplicity, let's only look at what the energy supply means at offshore level and what the demand will mean in the next slide. So when it comes to offshore energy generation, we have more or less three types of, or four types, if you want, of energy generation in the blue economy. We have the ocean waves, the tidal, the offshore wind, and also some solar in some cases, although a bit less when it comes to seas and oceans, but floating PVs. So how is digitalization actually helping this generation, this supply, energy supply? So first of all, through data, more and more we understand the natural potential of these environments, and we understand what are the places in which these capacities can be deployed effectively. So it's first a matter of assessing the right natural potential and the right location for these generations. Then it's also a matter of construction and design optimization, the way I actually deploy that. So once I decide that there is a natural potential in a specific area, the way I deploy that, the way I build those capacities, the exact location, the way I influence other, let's say, generators in my vicinity, it also matters. So on the construction side, the digital modeling and simulation are helping a lot in maximizing the potential, the natural potential that I can actually convert into power. Then on the operational optimization, it basically integrates real-time analytics. For instance, weather patterns or weather forecasts that are influencing my energy generation. And based on that, I take informed decision in order to maximize the energy generation that I get from my offshore assets. Then we are talking about digital twins. So not only that I'm understanding in real time how to adapt to that, but I'm also developing medium and long-term models, virtual models, that are basically simulating what is happening with my physical assets in the offshore areas. And based on that, I can actually have predictive maintenance, so I can understand in advance how my assets are being influenced by different conditions in the offshore environment, so I can act in advance, so I can prepare in advance for different, let's say, refurbishment processes or downtime processes, because I do expect this digital twin technology to inform me in advance about this potential downtime or issues that I may have with my generation. So this is on the supply side. When it comes to the demand, we are seeing more and more discussions about electrifying ports, so more and more conversion of energy demand into electricity demand in coastal areas. And we are seeing hubs being a very important nodal point for, in general, what it means global energy supply chains. They're functioning as hubs and gateways to that, and generation points for energy, even more so with this offshore generation. They're obviously adopting more and more renewable energy sources because it is an important trend, and it's an important, let's say, process that is going on with decarbonizing the consumption. And it's obviously implementing more and more decarbonization strategies. Once again, how is that being influenced by digital solutions, where it is enhancing and it is unlocking this system efficiency at consumption point. It optimizes the resources, the energy resources consumed by ports and by ships that are in these ports, and are supporting in general logistics and traffic management that obviously increases efficiency and decreases loss or downtime that is not efficient for everyone. In a summary, I thought that this is also a very interesting graphic. In a summary, it is about integrating different capacities, generation capacities, energy generation capacities into this blue ecosystem. That is unlocked by the digital solutions. It is about capacity building of this integration, and it is about shipping and demand in ports that are becoming more and more clean and more decarbonized. That is my part. I know that we will have Q&A at the end of the panel, so that was just a general overview of what the digital and the energy transition means for the blue economy. Looking forward to the panel, and thank you very much once again for the invitation.
Thank you very much, Andrei. Very, very interesting talk, and I look forward to the panel. And now I'd like to invite to the stage Mr. Pavel Dvořák, the development manager at Bamita in Slovakia. Oh, sorry, the mic. Oh, sorry. Yeah.
Did I need? No. Something. Hello? Yeah.
Yes.
Hello, everybody. Hope you are doing well. I'm excited to be here to present you on the theme Digitalization of Sustainable Blue Economy. My name is Pavel Doriak, and I'm from Slovakia. Slovakia is a landlocked country, so we don't have lots of oceans or seas, but that doesn't bother us at all because we have a lot of rivers which we need to take care of because inland blue economy is, in our opinion, more important as the coastal blue economy. This is the brief summary, what I plan to talk about today. Firstly, I want to talk about circular economy, renewable resources, fishing, digitalization with IoT, AI, and blockchain, and then I would like to talk something about our company. Linear and circular economy. Linear economy is now the mostly commonly used economy in around the world, and essence of profit in a current take, make, dispose system relies primarily on a high consumption on non-renewable raw materials, which logically cannot be sustained long term. When we added negative factors to the equation as exploitation of cheap labor, population explosion, increase of consumerism, and we have a really big problem with dispose of this waste. It's not very good, and it has devastating impact on all environment. Conversely, the circular economy is aiming to be competitiveness between the countries, stable economic growth, and the most important, healthier and cleaner environment. The profit of circular economy is based on efficient use of natural resources achieved through effective valorization of used product, materials, and components. Continuously returning these materials into cycle represent the closure of the material inflows. This really drastically minimize the production of the waste, cost of the material, and energy inputs. Renewable energy production. In terms of renewable energy production in the blue economy, mostly coastal areas are ideal for installation, wind turbines, tidal power generation, solar panels, and so on. Along the coast, wind is steadier and stronger than in the inland, and its force is unobstructed by any natural or artificial barriers as mountains or buildings. So it's ensuring a shorter ROI to the investments. Technically speaking, almost all countries with access to the sea or ocean has potential to transform its coastline to energy hub and producing clean and green energy. This energy can be utilized in industries or used by population, or can have a further positive impact on the environment. Sustainable aquaculture. We can ensure sustainable fishing through implementation of sustainable fishing practices, which includes establishing strict fishing quotas to prevent overfishing, protecting, restoring, and cleaning marine habitat as coral reefs, seagrass beds, and mangroves, and also creating marine reserves and protective areas where fishing is prohibited. This allows fish and marine life to recover and thrive. IoT. By utilization of automated processes using IoT system, we can achieve smart aquaculture and renewable energy optimization. About the smart aquaculture, IoT devices such as sensors and cameras can monitor water quality, oxygen levels, feeding patterns. This can be analyzed in real time and prevent diseases outbreak and improve overall farm management. In a renewable energy point of view, IoT sensors can be deployed on a wind turbine, solar panels, and all of the devices which generated electricity to monitor performance and energy output in real time. This can be used to reduce downtime, optimize energy production, and improve overall efficiency. When we use IoT devices, it's good to use also artificial intelligence that can achieve predictive analytics. For example, AI algorithm can analyze large data sets related to the ocean currents, weather pattern, and marine life behavior to predict future trends and events. This optimization can help optimize fishing practices, renewable energy generation, and waste management strategies, thereby improving efficiency and reducing environmental impact. Energy management. AI learning algorithm can optimize energy production and consumption in renewable energy system by forecasting energy demands, adjusting power output in real life, identifying opportunities for energy storage and grid integration. Overall, IoT working with hand-to-hand with artificial intelligence technologies have potential to revolutionize blue economy by improving efficiency, enhance environmental sustainability, providing valuable insight, and create more resilient, efficient, and environmentally friendly blue economy for future generations. Blockchain. Not Bitcoin, blockchain. The use of blockchain technology in digitalization of blue economy brings also several benefits and advantages. First of all, transparency and trust. Basically, what happened in blockchain stays there forever. Blockchain ensures immutable record of transaction and events, increasing trust among trustees. Transparency, resource traceability. Blockchain is a very complex concept. It's not just cryptocurrency, but it's also can be used on all of different stuff. For example, for recording entire life cycle of product from beginning to end. This can help to track the origin of raw materials as well as movement of the energy. Blockchain also enables the creation of DeFi and assets tokenization, opening up for new business opportunities for financing and investments. This type of technologies allow for greater participation by also small capital entities. Okay, and now our company, or my company. Now I would like to talk about it, about our project and our new product which we developed during this project. Our company primarily engages in the production of products made from recycled PVC material. One of our main products is anti-noise barriers, which we distribute worldwide, mostly to civil engineering companies and mining sites. Thanks to the Iceland, Liechtenstein, and Norway grants and EA grants, we take a participation on the project with the name Applied Research to Improve Acoustic Efficiency, Anti-Noise Barriers, and Ecological Use of Waste Generating during their production. This was basically our first introduction to circular economy. Results from this project is that we achieved the primary goal and we increased sound absorption of these anti-noise barriers thanks to the help with our friends in universities, which are here at the picture. Essentially, we more or less excelled in a secondary goal that we used material as, in a secondary goal to use waste material to something else, with that, we developed floating barriers, which looks like this, because yeah, this is our trial project. The waste, during the process of production, these anti-noise barriers was, yeah, we have a waste we cannot use, and we take that waste and try to make something from it, and yeah, this floating beam is the answer, our answer to it. So we basically have take a waste and make waste to catch another waste. So I think it's a nice idea. In terms of digitalization of this project, this is still in infancy at that time. But we are trying to implement IoT and AI to it, and we wanted to monitor situation around it as a quality of water, temperature, speed of water current, and quantity of capture waste, which can help speed up the process of cleaning water environment. Installation and uninstallation is very easy and very quickly managed. And of course, its small size almost doesn't interrupt the water wildlife around it. For me personally, I would be happy to, if I were a business owner, I would be happy to go bankrupt with this product, because that means that we don't have a waste in our environment, but this is not true right now. So, all right. Thank you for your attention.
Thanks. Thank you, Mr. Dvořák. Very interesting talk. And now I'd like to give the stage to Bartosz Lankowski, the Safety and Drone Services Project Manager at the Port of Gdynia in Poland. Take it away. Maybe keep the mic a bit
Closer?
Yeah.
Okay. Good morning, everyone. I'm very happy to be here today. Thank you for the opportunity. I would like to say something a little bit about the digitalization in Port Gdynia. We are trying to do our best, and the main thing is efficiency and the money. To optimization of the, to reduce the cost of the investments. We are in the north of Baltic region. We are not so big as the other ones, and we are close to Gdańsk, and as you see there's a Szczecin as well, so there are 3 ports in Poland. And we have established a variety of connections with other ports in Europe and in the world. This is this short invitation, I don't know, showing how and where we are. And this will be the short movie, and it will get you closer to the Port Gdynia, so you will see how we work and where we work and how the Port Gdynia is looking. There should be a nice woman saying something, but there is nothing, so only the movie.
Currently undertaking a significant renovation of the Hell Quay, spanning approximately 800 meters in length. Port of Gdynia Authority SA has received financial support from the State Treasury budget for the design and construction of almost 2.5 kilometers of new breakwaters. Port of Gdynia SA, NDI SA and NDI Sopot SA have signed a contract worth almost 83 million of Polish zloty gross for the construction of a dock recess and the reconstruction of a floating dock, including related works. South Quay, West Quay and Second Pier will also be reconstructed. As part of the investment, a new turning basin will be built to accommodate 400-metre vessels calling at Gdynia Port. Yandanol Group has completed and delivered the dredging of the inner basins of the port to a depth of 16 metres. The Indian Quay is currently undergoing reconstruction, with the main task being the widening and reconstruction of a 540-metre stretch. In 2023, nearly 90,000 passengers visited the port of Gdynia on 36 cruise ships. To summarise, 2023 was a year of considerable progress for the port of Gdynia, with a focus on sustainable development, technological innovation and collaboration with the local community. The port of Gdynia continues to be a regional leader, prepared for the challenges and opportunities that lie ahead.
So, as you can see, we are the special port because we are inside the city. So, in our politics, we need to cooperate with the city, and we need to be as eco as the city is. So, there are a lot of problems. In 2018, we started to thinking about the digitalization, but in the investments, we are trying to open up the port to the digital twin and to take all those buildings, roads, rails, which we are had harbors into our computers. So we started the process, and because of the pandemic times, of course, it's speeded up. So it was the time when we must move. We thought about all those things: how to connect with our investments, how to connect with our workers to do the job properly. So we thought that we do something like this to improve the collaboration, to communication, to reduce the amount of errors which are used to be and used to are in project, and especially investments when you are trying to build something. And we figured out that in this solution, the computer and the application which can show us how we do things, can show us the errors, the mistakes, there are not compatible things in many projects. It's a good idea. It's for sure. It's more efficiency, and for sure it's reducing the cost during the proper investment. When we are under construct, it's too late sometimes to change our mind, to change something in our project. So it's very easy. First, we model the harbor. It was during the pandemic, so we start with our architectures and with our constructors to do the first thing and first harbor in the digital version. So we digitalize all the elements of the harbor and of the piers as well, of the quay. And everything was digitalized. We reduced amount of paper, so it's very important not to cut the trees everywhere on the world. So we reduced amount of paper, and we did it quite well. So it was very fun to work on it. It was easier to share all those information between all the stakeholders and all the people invited into and involved in the project. And then we do the same thing with the depth of our harbor. So we did all those things. It's a funny thing because we used to have a project from the Norway grants, and in short term it's called Hydro drone, and we used a floating drone to do the autonomous bathymetry and collect all the data of the environment in water. So the project is finished now, and the main obstacle in this project was maritime law. Unfortunately, in Poland there is nothing about autonomous floating boats which can operate between the normal ships and normal harbors. So this was the very difficult part of this. We did the visualization on the depth to work in to work in normal stages at work. And then we put a lot of devices to measure all the things in port. So we have meteo, hydro, bio, noise, and air. Noise is very important in Port Gdynia because we are inside the city. So a lot of people around the port are like complaining that there are like always noises, and it's quite loud. But unfortunately, we are operating 24 hours, 7 days a week, so it's impossible to reduce those noise. But we are trying to convince all those people that it's not mistakes. So it's not because of us, because of the cars and other things. So we are collecting all those data and trying as well in this process to act as quickly as it's possible to minimize all the environment pollution or other things. Then in our work, especially because I'm using the drone all the time, and I'm responsible for all the operation with drones in Port Gdynia, we started to use the drones to do the photogrammetry and to use it in architecture and in projecting all those things. So you see this is the site of the under construction site, and we put the project from the paper from the computer on it to show where should everything goes. And we are like doing from time to time for I don't know maybe after 2 weeks or 3 weeks we are do the same thing. We will do the photogrammetry from the drone, and then we are connect all those pieces, and we can see how the investments are going and if we are in schedule or not. So it's a very good thing, and it's a cost effectiveness, and we are trying to reduce amount of errors. You see, we can use as well LiDARs, so we can measure all of the values of the volumes of the I don't know, some rocks, grounds or something like this. It's very useful, but we are starting to using it, especially because we have a lot of coal in Port Gdynia. So coal is like very important thing for now, and we are trying to measure all the volumes, and that's it. We are doing now as well modeling of all the buildings which we have in Port Gdynia, because Port Gdynia is like 100 years old, so there are a lot of buildings which are on the paper, and even not on the paper, they are just in Port Gdynia, because after the World War everything was destroyed, so we don't have any documentation about those buildings. So we started to modeling all those things and preparing ourselves for example for the sunlight analysis, and to figure out if we can and how it will be like the effective for implementation of the photovoltaic for solar panels. And this is the one of our investments. There's on the one of the magazine which we have in Port Gdynia. We cover all the roof. We cover with the sun with the solar panels, and we did all the analysis in the computer on our digital model. This is not this model, but we just prepared something on a different model, and we can do as well in this modeling. And I can say that we are not develop the applications. We are using only the application which can you buy on the market. So it's like normal things. We are not trying to, I don't know, figure out the wheel at the beginning like in the past. But no, we are using what we have, and that's it. We are trying to. I know there are a lot of applications, and you can do a lot of those things in a different ways in a different application, and there is no. And it does not easy and way to figure out which application is good. We are, for example, in here this Autodesk, but it's you can use all those available application here. And the other part is the wind. So of course, if you are next to the sea, you have a lot of wind for sure. And we can do all those analysis as well, as you can see, about the transport, structure engineering, wind energy. So it's again, it's like it's a future. You normally don't use it because it's like it's not typical. No one. It's again, it's costs. Because it's a strange thing, because you must pay for those applications. You need to pay for the architect, and you need to pay for everything which must be digitalized. And then you are doing analysis to reduce the cost. So it's like, okay, no, it's not normal. So, but I think that in the future it will be much easier. Yesterday it was on the stage, it was about hydrogen, that now hydrogen is very, very expensive, and it's more expensive than gas and other things. And now we have the same thing. All those things are quite expensive. It's like it's making more expensive for the project, but in the long term, the cost will reduce, and it's give you back with advance. So it's quite a good thing. For example, this is the one of our terminal. It's like it's a quite new thing, and we did all the scans. We use the drone scanners and mobile scanners. We scan the building inside and outside, and this is the effect of this scanning. So I think it looks very nice. As a digital twin, as we say about this at the beginning. So, for example, we are now at the stage 1 or even 0 with the digitalization, because we need to prepare all those things to implement all the devices, I don't know, firefighters devices, to the fire devices and everything into digitalization. So we are, for example, in here, you can see the part with the connected to the railway and to all the devices. We are trying to measure all the things and identify several wheel damage. It's very important, because if we are trying to take the call from the port and using the trains, it's important to not overload all those trains, because it can happen the tragedy or something like this, and it's again costs, and we are closed for some time, so it's like it's not good for us. So this is the part of the digital twin, and in long term we want to implement all those things in one digital platform to give, I don't know, my coworkers some platforms to see where is the train, for example, in Port Gdynia, if it's okay, everything with him, if there is enough safety security in the buildings, for example, I don't know, CCTV or other systems to protect our buildings and our port. And all those things will be in one place and divided only for proper persons in Port Gdynia. So to see only the main things, for not the most important things for them. So this is the first example. We invested in the new railway, and there are a lot of new devices which are measuring some things, and we want to develop and to put more those devices. As you can see, this with the bio and the green environment to see, it's very easy, because everyone is now green. Everyone knows how to pH detect, how to detect oils and everything in the water. So it's much more easier. But it's only the part, because it's like you know, there's like about the drones. It's the same thing, because we don't see any drones over the Port Gdynia, because many times you don't see it, and you want to protect, so you know, want to, like, I don't know, some detection to see if there are some unfriendly drones over the Port Gdynia, but there are no. So if we should invest in such a systems or not, because it's like, no, because there's nothing happened. So if nothing happened, so we don't need to invest any money into any project. So the same as with the environmental, but it's much more easier, and those devices are much more cheaper, because it's like, it's it's proceed for, I don't know, for 20 even more years. So now, we are now with the digital twin at the same level which we were in 2000s, because like at the beginning, all those things, all those the devices were very expensive. So no one could afford about all those devices. But now it's quite cheap. You can, I don't know, you can buy for forecast weather at home, and you can see what is like a temperature, wind, and other things, yeah, at your home. So it's not very hard. So yeah, we are trying. And the last thing, it's like only in buildings and investments. We can use all those digital things in variety of systems, and those. Oh, I'm too fast. And I don't know if some of you knows those systems, but yeah, in some investments in buildings, this is like very popular, and BIM as well, Building Information Manager. So this is the part of the digital twin as well. In conclusion, yeah, I have only 2 minutes. So yeah, time savings, as I said before, money costs, and analyze all the mistakes, errors, and eliminated them before the project will finalize. And I don't know. This is. We are going to green, but with the money. So it's like it's important to optimize of all of the process, stages of the process. So yeah, so that's it. Thank you very much for attention, and I hope it was quite interesting. Thank you.
Thank you very much, Bartosz Lankowski, for a very interesting talk on the Porto Gdynia. And I agree with you. We are going green, but with the money, you know. But due to the impeccable time management of our great speakers and the amazing moderating by me, we have 15 minutes extra break time. So go ahead and network, drink coffee, and chillax. I'll see you again at 11:40.